Let's get to the second feature of the system, which is the ability to log in. What we'll do is, while allowing this feature to come in, we'll try to improve architecture slowly. Every request that you're sending to your internal service has to be authenticated. There is no way around this. The reason for that is because if you log in and then you send an unauthenticated request and I accept it, that means that anybody who had not logged in also can send the same request and get their job done. For example, you say that, get me the emails in the past 1 day, all right? So that's a request here. It didn't have any authentication mechanism, means there's no username, password, nothing. So I say, yeah, here are your last 1 day emails. Okay, user ID XYZ, here you go. Which means that somebody in a separate computer can do the same thing, right? If I know your user ID, which is 123 or XYZ, I just send that request with the same params and I get the information. This might be private information. Worse, I can delete all your contacts. Worse, I can write emails for you. In fact, the SMTP server, the thing that actually sends email, had this issue. It didn't have authentication mechanisms as strong as it should have. We don't want that happening. So once you have logged in, technically what you're saying is that now you have a secret with you. Take this secret and any action that you're going to do on my service, send this secret, I will know it's you and I'll allow you to do that action. When you're logged in, I don't just send you an okay, I actually send you a secret. Every time you send your username with this secret, I know that this is the right user. So I don't just store the user ID, the timestamp and the code. When you have logged in, I make another entry saying that this user ID at this timestamp has a secret, which is going to be mentioned in the database tables, which they can use for subsequent requests. So what should this secret be? It could be their password. After all, a secret thing that the user contains, which allows you to authenticate them, is their password. But that's not ideal, although it can be done. There's something called a cookie in the browser where you can store some information. So when the user has logged in, what you do is you go to their cookie, the browser cookie, and you write down their username and password. That is one way to do things. Because every subsequent request that they're sending to gmail.com, you will append this username and password using the cookie stored in the browser and then send the rest of the request forward. So it might contain some parameters to search the email. So those are additional parameters, but you always stuff in these two parameters using the cookie through the browser. Not ideal. So instead of storing the password as plain text, you use something called a token. It's pretty interesting. The token basically allows you to create something like a session. You can invalidate a token. You can't invalidate a password that easily. The user has to update the password. But if you invalidate a token, their session is dead. So this secret can be invalidated, which is effectively a logging out of the system. When you do that, you basically say, the auth service says that anytime a person is trying to perform an action in the system, the gateway is going to ask the auth service, hey, is this person authenticated? The auth service is going to say, oh no, that token is invalidated. The one that they just sent you is invalidated, so no go. While if the token is fine, then the gateway gets a request, let us say search emails with some params. This is sent to the gateway. The gateway is going to forward this to the email service saying that get me the emails. But before it does that, it needs to authenticate a user. It needs to make sure that this is the guy who has access to those emails. So it first asks the authentication service again, which makes sure that the secret that they are sending, we used to stuff username and password. Instead, we are going to stuff username and token now. So is this username actually having this token validated? And if that is the case, go ahead. Otherwise, cancel, and you just fail your authentication right here. And so you don't get to see the emails that you are trying to get. Do you notice any issues over here? You might notice a lot, but the most obvious one is probably that this cache over here for the service manager was saving the gateway a lot of time, by not making this API call. We have the same issue again in the auth service. Any request needs to be authenticated, meaning that every time a request comes to the gateway, it first asks the auth service and then it forwards the request to the right place. So the job of the auth service, which is checking that the user ID and the token match the ones sent by the user, is going to be offloaded to the gateway, and the updation of this cache, very similar to the service manager cache, is going to be handled by the auth service. Okay, so what we have done is the number of API calls and the huge amount of load that we are going to send to the auth service has been completely removed now because you have added a cache over here at the gateway. All that responsibility has come to the cache of the gateway, which is being maintained by the auth service. So even now the responsibility of maintenance is here, all the code logic is over here, but the data is somewhere over here to speed things up. Anytime the service manager or the authentication service needs to update this, they need to be able to notify the gateway. So you need to have some sort of notification mechanism. The way you can notify is that you can use some sort of a message queue internally. So if the auth service needs to notify this guy, it uses a queue where it pushes updates, and these updates then are reflected on this cache over here, which is the authentication cache. And you'll see that there's strong coupling right now between the gateway, the service manager, and the gateway and auth service, okay, which is not a great thing. But for performance reasons, sometimes a little bit of coupling is okay. Any issues you see here now? Yes, there's a clear issue. The gateway is going to be storing this information inside itself. That's a lot of data, okay? And this thing of taking somebody else's data and then manipulating it so that you have more performant queries is an anti-pattern itself. Why is it an anti-pattern? Well, first of all, you have all that additional code and logic which you need for updating these caches. The second thing is you need to provision that much memory. You have bloated your service entirely. And the third thing is there's a lot of duplication. Duplication meaning that gateway is a distributed service. It's running on 3 boxes. So box A, box B, and box C. All of those 3 boxes need to contain the complete information of this cache and this cache. And you can imagine that if an update needs to happen, it needs to be distributed onto all 3 boxes. If you have 500 boxes, that becomes a fan out. Like you need to send that update request to 500 boxes which have to update simultaneously. It's a nightmare. We are not going to do this. We are going to take this information and store it in a separate place called a global cache. The cache is very similar to a map. It has a key and a value. So the authentication service says auth underscore user ID. The value that it's going to contain is what is the secret that this guy has. So every person mentions their service name so that you can differentiate between the service and what kind of information is it looking for. Whenever you have an update, you send it to this global cache. Because it contains all the data, the gateway can use this global cache to query every time it needs to route a request or authenticate a request. We are back to square one kind of, because we were saving on the API calls. Now by making the API call to the global cache, what the hell? I mean, the performance is bad. But the drawbacks in that system of storing things locally were too high compared to this, where you are making a single API call for getting all relevant information in one shot from the cache. As you look for more performance, you can kind of bring this closer and closer to this system, even inside it. But it's not ideal because there's so much duplication involved and so much update nightmares involved. So the service is nicely decoupled and it's still performant. So with these changes in our architecture, we can now take a login request from the user, send it to the authentication service, which generates a code that the user enters into the browser after reading from the cell phone. And then the authentication service says that yes, this user is now verified. Here's a secret which the user can use for all subsequent requests, which is like one session.